Welcome to the session on correlation in numerical and statistical analysis. I am Josmi Joseph, Assistant Professor of Computer Science. Various measures of central tendency and dispersion can be used for the purpose of comparison and analysis of data in statistics. Measures of central tendency gives a single most representative value to describe the data set. It gives the summary of the data, and in previous sessions we have studied different measures of central tendency like mean, median, mode and geometric mean. Measure in statistics is measure of dispersion, which gives the extent to which the values in a distribution differ from the average of the distribution. And we studied standard deviation as a measure of dispersion, and standard deviation measures dispersion from the mean. And these measures of central tendency and dispersion can be used for the purpose of comparison and analysis of statistical data. Statistical data are often classified according to the number of variables being studied. Distributions involving only one variable is called univariate distributions, and such distributions only we have seen in the previous sessions for calculating mean, median, mode, geometric mean, and for the measure of dispersion, standard deviation. Sometimes we may come across certain series where each item of the series may assume the values of two or more variables. For example, if we measure the heights and weights of n individuals, we obtain a series in which each unit or each individual of the series assumes two values, one relating to the height and other relating to the weight. Such distribution in which each unit of the series assumes two values is known as bivariate distribution, and it can be defined as the frequency distribution of two variables. In bivariate distribution, we are interested to find if there is any relationship between these two variables. If we measure more than two variables on each unit of the distribution, such distributions are known as multivariate distributions. In bivariate distribution, we are very much interested to find if there is any relationship between the two variables under study. For example, if we have the heights and weights of students of a class, is there any relationship between the height and weights? The correlation is a statistical tool which helps in this study, and it studies the relationship between the two variables. The correlation analysis involves various methods and techniques used for studying and measuring the extent of relationship between the two variables. The correlation between two variables tells us if there is any relationship between the two variables, and if the value of one variable changes, does the value of the other also change? Do both the variables move in the same direction? If value of the variable increases, what happens to the other one, whether it increases or decreases? And if the value of the one variable decreases, what happens to the other one? And how strong is the relationship between the two variables? So there are mainly two types of correlation: positive correlation and negative correlation, and linear and non-linear correlation. Let us see one by one in detail. If the values of the two variables deviate in the same direction, that is, if the increase in the value of one variable results in a corresponding increase in the value of the other variable, it is a positive correlation or direct correlation. Or if a decrease in the values of one variable results in a corresponding decrease in the values of the other variable, the correlation is said to be positive. Some examples of this positive correlation are the heights and weights of students of a class. Usually, when the height increases, the weight also increases. Another, the family income and the expenditure on luxury items. If the income increases, the expenditure on the luxury also increases. Negative correlation. A correlation is said to be negative or inverse if the variables deviate in the opposite direction. That is, if the increase in the value of one variable results in a corresponding decrease in the values of the other variable, or if the decrease in the value of one variable results in increase in the value of the other variable. For example, price and demand of a commodity. If the price of an item increases, usually the demand for that decreases. Similarly, the volume and pressure of a perfect gas. If the volume increases, the pressure of that gas decreases, or if the volume decreases, the pressure of the gas increases. The correlation between two variables is said to be linear if corresponding to a unit change in one variable, there is a constant change in the other variable. And if we plot the data in the xy plane, we get a straight line in this case. For example, these are the x and y values given, and x is independent variable and y is the dependent variable. And while plotting the graph, we will be plotting the independent variable on the x-axis and dependent variable on the y-axis. This table can be represented mathematically with the expression 2x plus 3. 2 into 1 plus 3, 5. 2 into 2 plus 3, 7, so on. This follows the equation 2x plus 3. So, this equation is similar to y is equal to mx plus c, where m is the slope of the line and c is the constant, and this represents a straight line with the slope m and makes an intercept c on the y-axis. If the values of these two variables, if we plot, it will come as a straight line like in this figure. The relationship between two variables is said to be non-linear or curvilinear if the corresponding to a unit change in one variable, the other variable does not change at a constant rate but at fluctuating rate. In such cases, if the data are plotted on the xy plane, we do not get a straight line. So, by mathematically speaking, a correlation is said to be non-linear if the slope of the plotted curve is not constant. Commonly used methods for studying correlation between two variables are scatter diagram, which represents visually the nature of association without giving any specific numerical value. Next, Karl Pearson's coefficient of correlation. It gives a numerical measure of the linear relationship between two variables. And third one is Spearman's rank correlation, measures the linear association between the ranks assigned to individual items according to their qualitative attributes. The Spearman's rank correlation is the only one which we can use for the qualitative attributes. Scatter diagram is the simplest ways of diagrammatic representation of a bivariate distribution to ascertain the correlation between two variables. We are given with n pairs of values x1, y1, x2, y2, etc. xn, yn of two variables x and y. These points may be plotted as dots on the xy plane. The diagram of dots so obtained is called scatter diagram. From scatter diagram, we can form a rough idea about the relationship between the two variables, but we won't get any numerical values from the scatter diagram. In scatter diagram, if the points are very dense or very close to each other, a fairly good amount of correlation may be expected between the two variables. On the other hand, if the points are widely scattered, a poor correlation may be expected between them. If the points on the scatter diagram reveal any trend, either upward or downward, the variables are said to be correlated, and if no trend is revealed in the scatter diagram, the variables are uncorrelated. If all the points lie on a straight line, starting from the bottom, left bottom and going up towards the right top, the correlation is perfect and positive. If there is an upward trend rising from the lower end and going upward to the upper right hand corner, the correlation is positive. On the other hand, if the points depict a downward trend from the upper left hand corner to the lower right hand corner, the correlation is negative, like this. This scatter diagram shows the perfect positive correlation with indicated by a straight line, and this one also shows a positive correlation but a low degree of relation. Here this diagram shows a high degree of positive correlation, and the other three, this one shows the negative correlation, this with a low degree of negative correlation, and this with a high degree of negative correlation. This shows the non-linear relationship, and here there is no correlation at all. Scatter diagram tell us about the nature of the relationship, whether it is positive or negative and whether it is high or low. It does not provide any exact measure of the extent of the relationship between the two variables. Let us conclude like this. The statistical tool that studies the relationship between the two variables is the correlation, and different types of correlation like positive correlation, negative correlation, linear and non-linear correlations we have seen. And the different methods of studying correlation are scatter diagram, Karl Pearson's coefficient of correlation, and Spearman's correlation coefficient. Of these, the scatter diagram we have seen here. So in the coming sessions, we will see the Karl Pearson's coefficient of correlation and the Spearman's correlation coefficient. With this, we are concluding this session. Thank you.